Hello, I'm Kevin. Jeff Kevin's PhD student, and I'm here to just wanted to informally share some really interesting stuff that had popped up when after I made the phylogeny surface. Um, anyway, cut a long for short. I'm not going to really go into depth about surfaces. I'm sure you've heard enough about them over the years. Anyway, but this was a anchored study with almost 1,300 gene samples, and I made an extensive effort to get almost all the genera possible using museomics. So I got 136 out of 135 genera, and which gave me an average of 700,000 nucleotides per taxon. And I developed a bioinformatics pipeline because I was not happy with my support values. Anyway, this is what the family structure came out as. We had the microdons at the top, then Merodontidae, the Syrphidae, which are the last units. I had the polycell lines, and then this is our two aerosolinae, sister to Fusionae and Syrphidae. So was parabolic all those years. Anyway, the first of the relationships I wanted to talk to you about is a really weird one, and what we're going to call the Salatini. Really bizarre because we have a neotropical species, a sister to basically an Australian plague, which has dispersed out of Australia in a single dispersal. So this plague represents all the whole Arctic and Oriental species, which have basically dispersed. It's a single dispersal out of Australia. And we have a superspecies plague in Australia. Sister to that is another neotropical plague and an old world plague. Although I'm not convinced that I've fully sampled this plague yet. So I'm like, oh, this is really weird when I first saw this relationship. And what's also interesting is that these are also wood associated. So how would such a relationship happen? As I'm sure you guys all know about Syrphidae, we love to show pictures. So these are some of the relationships flies in this group. Great pictures. Anyway, another interesting one are the Tropadites. Again, we're seeing these really weird neotropical Australian relationships. What's going on here? And a little different here. We get some Oriental species, some African species. Okay, that puts a little bit more on solid ground. And now we're getting neotropical species, Arctic species, and which is just so okay. Maybe they originated in the New World and made it out to the world. It's a little more solid ground. But I don't know what's going up there at the top. Anyway, so these are some of the flies in this group. So one of the things I thought is, this is just good old rattling. It's possible that we had flies getting washed from Australia to South America, flies from South America. It just be crafting. Good old maybe Thor figured all how to write all along. I don't know if any of you guys know on Tiki. A little bit of an old joke. So crazy theory that humans colonized the Pacific Ocean from South America. And he was so sure of this idea that he built this rickety old canoe and sailed from South America to Polynesian Islands in 1947. It's a crusty crap too. Anyway, there's one other group up at the very top, deep top, which I call the island of misfit flies, because I'm still not sure if they're actually related or not, or if this is just some artifact of my analysis. But again, because this is really just the grab bag of surface. This is the weirdest flies all came out here. And again, we're seeing neotropical and Australian. And what's not shown here is that there's a second, unfortunately I wasn't able to get data out of it, but there's an undescribed Australian genus, which is certain this is to this group. But I'm certain it comes up here. This is my little island with flies. Some of the weirdos. And this is the big one. This is the goodie. This is what made me go, what in the world is going on here? Now, what do you think the relationships in this group might be? I think I've given some hints so far, but I've got repeatedly visited neotropical Australia. Here's what the relationships look like. So the red dots are Australian, and the blue dots are basically Chilean. What's going on here? This had me stupefied when I saw it. So we have repeated, we have Australian. This is you can kind of ignore this. This is a whole Arctic plate. You have Australian with a neotropical somehow dispersal, and then where is it? And then more neotropicals, Australian. So I was like, huh, maybe it's not just rafting after all. Oh, what else could this be? So here's some of the pictures of this one. It's not like these are, oh, the other thing is this is relatively shallow on the surface. This is basically what I would call a subtribe. So this isn't like this is an old relationship. This is relatively new. So speculation. It's, as I said, it's difficult to conceptualize these as rafting events. Could this lineage be a remnant of a southern supercontinent? What do you guys think? So the current accepted kind of consensus, call it that, is that Australia and Antarctica began to separate about 33 million years ago. And Antarctica and South America began to separate not long after. With the circumpolar current not forming until about 23 million years ago. So that could be, it's not 60 million years ago as they thought maybe 2 decades ago. It's quite younger than that. So could relationships we think are Gondwanan actually be more recent? So moving forward, I need to get a molecular clock of these to actually figure out what the estimated age of this group is. Is it correlate with this quantum theory? Are they younger? Or are they older? If they're younger, that would lend evidence towards a rafting theory of oceanic dispersal. All what's interesting is all those claims you saw with the Australian and the neotropical relationship are wood associated. You don't see this in the really in the Syrphidae surface or in the rotting plant materials. It's the wood associated surface you see this happening. With uncredence towards this perhaps being a storm sweeping a big old tree out to sea, and it's bobbing over the ocean current. Maybe. But anyway, maybe all of our surface are, there's not many surface fossils either, so maybe all our surface fossils are anything Antarctic ice. So it could be a positive World War, maybe.
It's stupid gear.
It's stupid gear, oh, that's possible too. Maybe like one of those Bruce Willis movies where they're drilling through the ice. Anyway, that's really the whole talk. I was just like, wow, this is interesting. I wanted to share it with people. So, what are you guys thinking? Yes,
So, are there no species in New Zealand?
what's really interesting is, yeah, there are a few groups that get to New Zealand, but really the only one of these groups that make it is all the way back here. This group. This is the only group that makes it to New Zealand.
That's it?
That's it. None of the others make it to New Zealand. There's other surface in New Zealand, but they're not part of these neotropical Australian relationship plate groups. There are other groups that are in Australia that have made it to New Zealand.
And the African ones, where are they in Africa? Are they like Draken's
Madagascar, so the most primitive ones are basically Madagascar. What I think has happened is this is probably oceanic dispersal. The most primitive ones are actually live in the Penzosurface, the pitcher plant obligates, and I think there was probably a rafting event in Madagascar, and then from Madagascar they made it to the rest of the continent.
Okay. Can you up the slide?
Yeah.
So I guess my one issue is you're using species as exemplars for whole groups because Syrphidae is also North American.
That's a human. Syrphidae is a human. There's no native ones,
Okay.
so
But
the species is spread to North America is originally.
but still, throughout this analysis, are you using these as exemplars representing the whole genus? Or
So in most cases, the species is the whole genus.
There's the problem.
But
The genera are the problem.
would you really call this and this,
Depends how you define the gene.
or this and this the same genus?
Depends.
Although the characters are fantastic, they're quite easily distinguishable.
Because these are, as you said, all species.
Yes,
Okay.
pretty
That was,
much.
I guess that was what confused about.
This is monophyletic. This is a large clade, but I've sampled multiple species. Monophyletic. There's 6 species here, which I've sampled 2. There's 6 species here, which I've sampled 2. But they're all, again, so hemilamprey is only in Australia. I mean, this is only in Australia. This is only in the tropics. These are monophyletic. This is only in the tropics.
Okay. Yeah.
So I wouldn't have brought these up if they weren't basically exclusively within these regions.
So it just suggests to me that these splits must be much older.
I would not be surprised if Syrphids are older than people think they are.
This looks like a whole bunch of pellets. Like this is the only thing left in the whole bunch.
Yeah.
What are the weights of these versus?
So what's really interesting, I mean, I don't have the tree on this slide, but yes, look at that, all the way to the start. So what's interesting in Syrphids is you get beautiful long stems all the way until you get Aristotelidae, and it's just massive radiation within Aristotelidae that's just almost purely parallel. You're looking at the hideous little stems, hideous little stems you've ever seen.
Yeah.
Oh, I see. Okay. That was a big understanding.
Yes.
So, saying the trees,
Yeah, what are the
isn't known for many of them. It's not the Fagus, really, the big one. For some of them.
It used to be
Mhm.
much insects that you find, they look like they have unwanted distribution.
Possible.
There's an important paper by Hennig, I think 66 on the fauna of the New Zealand or something, where he points that out almost exactly, that there's just having these distributions doesn't really mean anything in terms of Gondwanan and vicariance. And he gives a number of examples of where there's actual fossil records, whole Arctic, within the whole Arctic of various groups that are now just restricted to these few places. That's worth looking at.
So like a multiple parallel
Problem.
relic.
One power
Yeah.
stems, where
Yeah,
are the
but
fossils?
it's a pattern produced by extinction.
Yeah, and South Africa.
Yeah. Especially when there's no fossils, right?
Yeah, basically no certain fossils. They just show up all of a sudden. The modern genera.
What's the earliest?
But the
I think literally just start showing up in the universe, the modern concepts in general that we know.
That's very interesting.
Yeah, no, there's only 60, I think, Syrphidae fossils.
Yeah, but there's hardly anything big in amber anyways.
Even the little ones, they're not there, and they do show up. I could easily classify them in our on site.
Did we made a custom pipeline for this?
Yes.
Can you tell us a little more about that?
I had a talk yesterday on that. That would be a very long diversion. Yeah. That's kind of the answer, but a little bit. It's a Python package that's built to replace basically orthograph or MCE. So it's that last one. Or HRAM, and it's something I made because I was unsatisfied with the current solutions, especially trying to recover relationships in RSValme. I went from support values of about 60, and once I fixed the bugs in the existing pipelines, my support values went up to about 90%. And once I discovered that mapping for each was better than building assemblies, my support values went up to around 98%. So, but that wasn't the focus of this talk. The focus was, boy, these are weird. And we see, yeah, I see much more standard relationships in the other groups. It's really only these Chilean, Australian ones that have me scratching my head. What's going on? Because most of them don't make it out of really the Andean range, high elevation. They don't make it out. There's a few dispersals out of them. When you do see them, these plates make it out, there clearly looks like more dispersals outwards from within the groups. So when they do make it to the large region.
I can't speak with a lot of authority, but my memory of a lot of different groups, like Ampids, for example, in Chile, is that it's a lot of relict groups that just don't occur other places, and occasionally you get some that are connected to other really isolated things that might be in like places like Nepal or Chile.
There's been some papers recently saying, looking at a Transantarctic dispersal, showing it's several entrance groups, not diphtherids, about 30, 40 million years ago. Which, again, what I would conclude these relations so far is going to depend a lot. My hypothesis for these relationships is going to depend on what the molecular top is saying is how old these are. Because if it's 10 million years old, my hypothesis would be that's probably rafting to some degree. If it's older, I think it might be. I think we could start looking into vicariance.
I feel like this is so much fun for us to talk about because we're at a point now where the trees are becoming more and more well resolved, and we're convinced that there's real signal in them, and that means the evolutionary questions are becoming much more possible for us to really take seriously. You know what I mean? Like we're not shooting in the dark so much about these evolutionary questions. It's now like, okay, now we have a specific hypothesis about the distribution of these things because we have trees that are resolved so convincing. So I think it's a fun thing.
What I was hoping.
But that begs the question too, how does this match morphological
Before I even went in to the tree rider, basically reflected Thompson's thoughts in some ways, in many ways. Thompson had something was going on here, and he hypothesized a few of these relationships. Specifically, this one, he knew this one back in the 70s. This is a circle this one back in the 70s.
And did Chris really do cladistics? Did he actually identify synapomorph? I always thought he was
did,
working
yes,
more
for this
from
group,
it.
actually, he did.
He
In
did
his
in his thesis.
1972.
Yeah, in his thesis,
Malaysia,
but in his
his
publications, it
thesis,
was more.
He
like
recognized
little
this
ones here and there.
relationship in his thesis.
He never did a big family level.
No, actually identifying it's an apomorphism.
Well, what's interesting is that, in a sense, somewhat, yes, because this clade was a heavy focus of his thesis. But he didn't quite catch that maybe these were all related. I think perhaps because he didn't focus so much on Australia.
Do you think there are good characters there?
Oh, there absolutely are
Lots of good synapomorphs to interpret?
Specifically for the silent team, I've already identified great characters. Very unique.
Very interesting.
Yes, there's a pile character which is basically almost basically exclusive to this clade, and there's a clade deep within another tribe. And let's see that. Thanks.
I'm glad we had a short schedule, because that was a really interesting discussion. I don't have any concluding remarks, other than it's great to see people here. Yeah, so if anyone wants to continue those sorts of discussions, that's great. If not, I could use a beer. I don't know about anybody else.
Yeah.
All work for Steve. Have a good night, everybody.